In this video, I will explain you how to solve memory ROM and RAM interfacing example, and this question is asked in the exam in May 2023 in Mumbai University question paper. So what is the question is given? Design an 8086 microprocessor based system with following specification. The first one is our 8086 microprocessor is working at 10 MHz in minimum mode, and there is 32 KB of ROM using 8 KB of devices, and the third one is 16 KB of RAM using 4 KB of chips. So based on the given data, we have to draw the diagram for the ROM and RAM interfacing, as well as we have to find out how many number of address lines will be required, number of sets and number of chips will be required, and what is the IC number for our ROM as well as our RAM. So in this example, what is given? Our microprocessor 8086 is working at 10 megahertz and in minimum mode of configuration. So I'm writing here MN MX bar pin of our 8086 is connected to VCC. That we have to write here in the answer. And the second one, 32 KB of ROM using 8 KB devices. So depending on the data is given, I'm writing here the total size of ROM and available size of ROM. So the total size of our ROM is equal to 32 KB and the available size of our ROM is equal to 8 KB. So based on that two data, I'm finding here the number of chips will be required. So I'm finding here number of chips is equal to total divided by available size. So the total size is 32 KB and the available size is 8 KB. So 32 divided by 8 is equal to 4. So there are 4 chips will be required. And in that 4 chips, I'm finding here that 2 chips will be used for the even memory set and the 2 sets will be used for the odd memory set. So first of all, we are finding here the number of sets will be required. So whenever I am finding the number of set, that time I am finding here number of chips divided by number of banks. So there are total 2 banks will be available. That is called as a memory bank. First one is even memory bank and the second one is odd memory bank. And we got here number of chips is equal to 4. So I am writing here 4 divided by 2 is equal to 2. So there are 2 sets will be required for our ROM structure. So now you can write here, whenever I'm using the 2 sets of ROM, then it consists of, first one is even set of our ROM 1. So this is our even set of ROM 1. As well as our odd set of ROM 1. And the second one, we require another set that is even and odd set of our ROM 2. So whenever I'm writing here even set of ROM 1 and the odd set of ROM 1, so it will become 2 chips. And whenever I'm writing here even and odd set of ROM 2, so there are 2 chips will be available. First one is even set of ROM 2 and second one is the odd set of ROM 2. Same like that. So there are again 2 chips will be there. So 2 plus 2, there are total 4 chips will be available in case of our ROM structure. So here we got this number, that is 4 chips will be required. Now currently we have done with that our ROM structure. Now we have to identify how many RAM structure will be required. So I'm writing here the third point, and what is given in that example, the 16 KB of RAM using 4 KB chip. So I'm writing here 16 KB of RAM using 4 KB chips. So the total size of our RAM is equal to 16 KB and the available size of our RAM is equal to 4 KB. So based on that data, I am finding here number of chips will be required. So how many chips will be required? We can identify it by using total size divided by available size. The total size is 16 divided by available size is 4 KB. So 16 KB divided by 4 KB, we got the number that is 4 KB. Now, depending on that 4 KB of data, we require 4 chips in that example. Now, the next one is we have to identify how many sets will be required. So, I'm writing here number of sets required. So, we are finding this number of set based on this formula, that is number of chips divided by number of banks. So, number of chips will be 4 divided by number of banks will be 2, that is even and odd, and we got the answer 2 sets of RAM will be required in that example. So again, whenever we require the 2 sets of RAM, that time we are finding here the even and odd set of our bank. That is even and odd set of our RAM 1, and here even and odd set of our RAM 2. So here also the 2 chips will be used for our RAM structure and the 2 sets will be used for our even and odd structure. So 2 plus 2, it will be 4 chips will be required in our RAM structure. One for even, this one is for odd, this one is for even, and this one is for odd. So how many it will be required? 4 chips will be required based on that given data. Now currently you have identified the ROM and RAM structure, that is number of chips will be required and number of sets will be required. Now I have to identify number of address lines will be required for our RAM and ROM. First of all, we will calculate it for ROM and then we will calculate it for RAM. Then the first one is we have the available size is equal to 8 KB. So we have the available size is equal to 8 KB. So I am finding it there 8 KB into 1024 memory location. So I am writing here address lines will be required, that is number of address lines that is required is equal to 8 KB into 1024 memory location. So whenever I am finding here 8 KB into 1024 memory location, so 8 is equal to 2 raised to 3 and 1024 is equal to 2 raised to 10. So 2 raised to 3 into 2 raised to 10, it is nothing but 2 raised to 13. So there are 13 address lines will be required. So I am writing here 13 address lines will be required and the name of the address lines will be A1 to A13. Why I am taking here A1 to A13? Because whenever you have two types of banks will be there, that is even bank and the odd bank, that time you have to remember always that there are two banks, even set and odd set of bank. And in that even and odd set of bank, we are connecting this address line 0 to our even bank and we are connecting this pulse high enable signal to our odd set of bank. That's why we have taken here line number A1 to A13. Now I have to finding out the IC number for our ROM. For the IC number for our ROM, I am taking here the 8 KB of data into 8 bit. So 8 into 8, that is 64 bit of data will be there. So IC number for our ROM is equal to, I'm writing here number prefix, that is 27 for our ROM, and after that I'm writing here 64. So the IC number for our ROM is equal to 2764. Now we have to finding out number of address line will be required for our RAM and IC number for our ROM. Previously, we have calculated it for our ROM structure. The same procedure we have to apply it for the RAM structure. So I'm writing here the available size of our RAM and ROM will be given in that example. So the available size of our RAM will be given, that is 4 KB. So I'm writing here 4 KB and the number of address lines required, that is 4 KB into 1024 memory locations. So for the number of address line, I'm writing here 4 KB into 1024 memory location, so that you can write here 4 is equal to 2 raised to 2 and 1024 is equal to 2 raised to 10. So 2 raised to 2 into 2 raised to 10, it will become 2 raised to 12. So there are 12 address lines will be required. So I'm writing here 12 address lines required, and the number will be A1 to A12. Now I have to identify the IC number for our RAM. So for the IC number, I am writing here 4 KB into 8 bit. So we are using the 8 bit of input and output, so that I am writing here 4 KB into 8 KB. So 4 into 8, that is 32 bit. And we are writing here the IC number for our RAM is equal to 62 is the prefix for our RAM structure, and then whatever the number we got from our previous calculation, that is from 4 into 8, that I am writing here, that is 6232. So 6232 is the RAM structure, RAM number for our IC. So currently we have completed with our theoretical part of our example. And in that we have identified the number of chips will be required, number of sets will be required, then the address lines will be required, and the IC number for our RAM and ROM structure. Now let's see begins with our drawing part of our example. So now we have to draw the diagram, that is memory interfacing diagram, based on the example that we have already solved. So here you can check what is the IC number for our ROM and RAM structure. So here the IC number for our ROM is 2764, that I have written in that structure. And the IC number for our RAM is 6232, that is written in that our RAM structure. So one part will be used for the odd and the second part will be used for the even. Here we require total 4 chips in that ROM structure as well as in our RAM structure. So whenever we have calculated these 4 chips, there is an even and odd set of ROM 1 will be there, even and odd set of ROM will be there, so that we require here one chip will be for even, one chip will be for odd, that is for set 1. Then one chip will be for even, one chip will be for odd, that is for set 2. So we require total 4 chips in that diagram. So if we have already these 2 chips, so I'm writing here this symbol and it will become 2 chips for our ROM set of odd 1 and 2. And whenever I'm writing this symbol here also, then it will become 1 plus 1, 2. Here also in the case of RAM structure, we require 4 sets required, 4 chips required, and there are 2 sets will be available. That is even for RAM 1, then odd for RAM 1, and next one even for RAM 2 and odd for RAM 2. So there are total 2 even chips will be required for RAM and 2 odd chips will be required for odd RAM. So I'm writing here this symbol and it will become 1 plus 1, 2, and this will also become 1 plus 1, 2. So now in the diagram we have 2 sets of ROM for odd, then 2 sets of ROM for even, then 2 sets of RAM for odd, and 2 sets of RAM for even. So in the diagram, we have to extend this burst high enable signal as well as our address line, then our data line, and our memory read and memory write signal. And now we have to give the connection in that diagram. So for example, you can see here in the ROM structure, we have only read signal will be available. So I'm connecting this read line and I'm writing here RD bar. So each and every connection of our ROM set, that is for even set as well as our odd set, we have to connect this read bar signal. So I have given this connection here. Now, whenever I am considering the RAM structure, there are 2 signals will be available, that is read and write signal. So here it is a read signal and here it is a write signal, that is memory read and memory write. And with the help of these two signal, we are doing a memory interfacing. So I'm connecting this read signal as well as this write signal. So now we have done with that read and write signal. Now I have to connect the data lines for our data bus for our ROM as well as RAM. So here you can consider this technique whenever we have to connect our data bus to our even RAM. That time we are using this D0 to D7 line. And whenever we have to connect the data signal for our odd RAM, that time we are using this D8 to D15 line. Total there is 16 bit of data bus will be available in our 8086 microprocessor. And further, it will be divided it into two types of memory bank, that is even bank and the odd bank. So for the odd structure, I am writing here D8 to D15. And for the even structure, I am writing here D0 to D7. Same it is applicable for our RAM odd set and the RAM even set. So I am writing here this even set D0 to D7. And for the RAM odd set D8 to D15. Now I have to connect the data line. So here is your data bus, that is from D0 to D15. So just you have to attach this connection as like this. So now I have connected the data bus. Then the next part is we have to connect the address line. So how we are connecting this address lines? Take the connection and we have to draw it to our address line. So here is the address line. So I'm connecting this address line and given that data that is required for our address line connection. So what is the address lines will be required? How many address lines will be required? For the ROM, we require 13 address line, that is from A1 to A13. And for the RAM, we require 12 address lines, that is A1 to A12. So this number is required here, that is A1 to A13 address lines for our ROM and A1 to A12 address line, that is for our RAM. So now we have done with our four connection, that is read signal, write signal, second one for the data signal, and the third one that is the address line signal. So read, write, data bus and address bus that we have connected to our 8086 microprocessor, and we have done this interfacing with the help of this ROM and RAM devices. Now there is one more important question, that is how we are connecting this chip select signal. For selecting this chip select signal, we have two symbols, that is odd and even. So these are the two types of memory banking will be available, and for the even banking, we are connecting this A0 line. So where is the even banking? That is the ROM even. So I'm writing here A0. Here is also I'm writing A0. And for the odd, we have to connect this burst high enable bar signal. And this is our burst high enable bar signal. And how it is activated? With the help of this chip select signal. So I'm writing here burst high enable signal. That is for odd ROM, and for the odd RAM, I'm also writing here burst high enable signal. Now we have done with our one input for our OR gate. The one input is still remaining, and that we are taking for this Y0 to Y7 output lines. So here you can consider that in that 74LS138 3H28 decoder, we have these three input lines. So the remaining three address lines, that is A19, A18, A17, that we are considering it for A, B, C input. And this Y0 to Y7, these are the 8 output lines in our example. Now you can see that we are using this 13 address line for our ROM and 12 address lines for our RAM. And the A0 is always used for our even banking. So out of that 20 address lines, we are using A0 to A19. The signals will be available for our address line. So A0 we have already done with our even memory banking. A1 to A13, that address lines we have already done with the help of our ROM structure. And out of that, the 12 address lines we have done with our RAM structure. Now, line number 14 to line number 19, it is remaining, and that we have to connect with our 3H2 decoder. So the last three lines, that is A16, A17, then A18 and A19. So these three address lines we are using it for A, B, C input. So when we are using these three lines for the A, B, C input, then out of that A14 to A19, our A14, then A15 and A16. So this will be required to connect to our LS70, LS138 3H2A decoder. So these three inputs, I am giving it to the D, that is our don't care condition, and that is connected to our ground. So A14, 15 and 16, these remaining three lines, I am giving it to the ground connection. So that is not required in this current example. So now check here, the one connection, one input is required for our chip select signal. One is already used as per the even and odd memory bank, that is bus size enable signal is connected to odd memory bank, and the A0 signal is connected to the even memory bank. Now check here, as in truth table, there are Y0 to Y7 outputs will be there. If it is a 0, 0, 0, then even and odd set of RAM will be used. If it is a 0, 0, 1, then even RAM will be used. If it is a 0, 1, 0, then odd RAM will be used. And now, in case of ROM structure, we are using this Y4, that is 100, for our even and odd set of ROM. And for the Y5, we are using it for even ROM. And for the Y6, I am using it for odd ROM. So even and odd sets are there in our truth table. So out of that, we have to select the lines. So for the ROM structure, Y4, Y5 and Y6. These inputs are available. Now my ROM is odd ROM. So for the odd ROM, I am taking either Y4 or Y6. So out of that two signal, if suppose I have to select this Y4, so I am writing here Y4 signal to our odd ROM structure. And for the even ROM, I am taking this Y5 as well as our Y4 signal. So Y4 is already used in that odd structure. So I am taking here Y6, Y5 signal for our even ROM structure. Now I have to connect here the RAM structure. So for the RAM, the even and odd sets will be there. For Y0, that will be used for even structure, as well as Y1 is used for our even structure. So Y0 and Y1, out of that two lines, suppose I am selecting here Y1. So Y1 will be given to our even RAM. Now for the odd RAM, there are two signals. First one is Y2 and second one is Y0. Suppose I want to select here Y2, then I am writing here Y2 as an input for our odd RAM. And with the help of chip select signal, we are selecting that line, and now our diagram is completed. So here in that memory interfacing diagram, first of all, we have to give this connection, that is for read signal, write signal, data lines, address lines, and with the help of this OR gate and our even and odd set of memory banking, we are selecting this even and odd memory lines, as well as our A0 and the bus high enable signal will be connected to our odd and even set of memory bank respectively. So now we have done with our example, and this type of question will be asked for 10 marks in the exam, and this particular question is asked in the May 2023 Mumbai University question paper. So in this way you can solve this example, then you will get 10 marks. This diagram is for 6 marks and the description consists of 4 marks. So for this part 1, 2, 3, whenever you are calculating number of address line, the IC number, number of chips, number of sets, what is required for this RAM and ROM, then you will get 2 marks for each. So this you will require 2 marks, and this you will get 2 marks. So for 4 marks, the description is there, and for the 6 marks, diagram will be considered. So if you solve all this type of question in well manner, then you will get 10 out of 10 in the exam.